Now let's simplify our like terms for our final example of the distributive property. Here we see three sets of like terms: positive 2xy, negative 2xy, and negative 7xy. 6x squared is a term of its own, so let's just bring it down. So we have 6x squared. Now, what is positive 2 minus 2? That's 0, and 0 minus 7 is negative 7 times x times y. Now, let's look at the shared division property. The shared division property is used when two terms are divided by a common amount. So for instance, any time that you use a fraction bar as a grouping symbol, the shared division property is an alternative. Now, using the order of operations, since this is a numeric expression, we could simplify this. 15 plus 15 is 30, divided by 5 is 6. That's using the order of operations. But instead of using the order of operations, if we use the shared division property, we can divide each term by the divisor they share. So for instance, this 15 is being divided by 5, and this positive 15 is being divided by 5. So an alternative to 15 plus 15 divided by 5 is to divide each term by the 5. So for example, we'll divide this by 5 and we'll divide this by 5. So it's equal to 15 divided by 5 plus 15 divided by 5. Now since this is numeric, we can simplify this. 15 divided by 5 is 3 plus, since it was a plus in the middle, 15 divided by 5 is 3, and we get 6. So you can see that the shared division property works. Now, for numeric expressions, it's a little more work, but for algebraic expressions, it's our only option. Algebraically, the shared division property looks like this. If you have two terms being divided by the same factor, then you can divide the first term by the factor and add the second term divided by the factor. Sometimes this addition sign will be a negative sign. You have to grab the sign in front to be sure that you are using the correct signs. And this property, like the distributive property, can be applied to more than two terms. Now, at the top I have reminding you the definition and algebraically what the shared division property looks like in case you need to look up there. So let's look at 4 examples. We have 100 minus 8 divided by 2. If we use the shared division property, we can take the first term, which is 100, and divide it by the factor, which is 2, and then subtract the second factor the second term divided by the same factor, which is 2. So 100 divided by 2 is 50, minus 8 divided by 2, which is 4, and we get 46. Now, we can do the same thing for an algebraic expression. We will still take the first term, which is 9a, and divide it by the factor, which is 3. Okay, see how we did that? And then we'll take the second term, which is negative 3b, and divide it by 3 as well. So we'll have negative 3b divided by 3. Now, we can simplify this because you can see that there are constants being divided, and those constants share a common factor. 9 divided by 3 is 3, and the greater amount was on top, so we get 3a. Negative 3 divided by 3 is negative 1, or just negative 1b, or negative b. So it's equal to 3a minus b. And you can see how we've simplified it. Do you see how it is smaller than here? Yet they are still equal in value. Alright, let's look at number 3. We have two terms being divided by the same factor. So we're going to divide each of those terms by that factor. So we get 6x, which is our first term, divided by 2x, minus 10y divided by 2x. Second term divided by the factor. Divided by the divisor. Now, if we look just at our first term, we have 6 divided by 2. 6 and 2 can reduce by 2, or they can divide each other. So 6 divided by 2 is 3. The 3 will go in the numerator since the greater amount was on top. We can also simplify division of the same base. We have x to the first and x to the first. If we subtract the exponents, we get x to the 0, which is 1. So this will eliminate because it equals 1. Now we have negative 10 divided by 2. So we get negative 5. And the y and the x are not the same base, so they just remain y over x. So we have 3 minus the quotient of 5y and x as our simplified expression. Alright, our last example. We have 8 times x to the 6 minus 6 times x to the third, all divided by 2x squared. So you can see that there's two terms being divided by the same factor. So we're going to write the first term divided by the factor minus this, because it's a minus sign here, the second term divided by the divisor. Now let's look at simplifying the first term. We have 8 divided by 2. 8 divided by 2 is 4, and it's bigger in the numerator, so put the 4 on top. And we have the same base being divided. We have x to the 6th divided by x squared. 6 minus 2 is 4, so we get x to the 4th power. Now, in our second term, we have negative 6 divided by 2, which makes negative 3. And we again have the same base being divided, so we get x to the 3rd divided by x squared. If we subtract the exponents, we get x to the 1st, and it will go in the numerator, so we get x to the 1st, or just x. So our simplified expression is 4x to the 4th minus 3x. Some of you may be able to do it without this step if you just kind of think, I gotta do these two, and I gotta do these two. You might be able to visualize that. So let's summarize what we've learned. Today we learned two new properties that help us simplify algebraic expressions. We used the distributive property, which is a multiplication property, and the shared division property, which is a division property. Both properties are alternatives to the order of operations. The distributive property is a multiplication property that says, instead of using the order of operations, multiply each term by the factor they share. Algebraically, it's represented by, if you have a factor times a sum, then multiply that factor by the first term and add the factor times the second term. The shared division property is a division property that states, instead of using the order of operations, divide each term by the divisor they share. So algebraically, it's represented by, if you have two terms being added, divided by the same divisor, it's equal to the first term divided by the divisor plus the second term divided by the divisor.